At the back of the inlet manifold, which I'm struggling to show you, is a crossover pipe which does balance the flow between the two banks. So if one side has a lot more pressure than the other, it will try and equalise it for you. But there's an important point here. If you fit an intercooler that does not keep the flow on the same side of the car, and it crosses over, then it will cross over again on this inlet manifold, and the engine management will get confused because it thinks that this MAF sensor here works together with this throttle here. But if your intercooler crosses the flow over instead of keeping it on the same side, it will mess up your idle, and what the engine will do is it will take a minuscule difference between the two banks and it will try to correct it by opening and closing the throttle, and you'll end up idling with one throttle open and one throttle closed, and you'll end up with P0700 codes and all sorts of trouble. So if you are fitting an intercooler, some of the Grady ones, Esprit, Forge are the ones I'm most familiar with. If these are swapping your banks around, you need to change this setting in the software. You need to select MAF swap A and MAF swap B to make that work properly for you. Okay, we're about rounding up now and my hands are cold. I'm not going to crawl under this car, I'm a computer guy. You can look at other stuff for what the exhausts do, but in outline there are 4 cats and 4 lambda sensors, which is a huge count. In the downpipes, as they come out of the turbo, you won't see them, they're all under all these heat shields under the side here. You've first got a wideband oxygen sensor or lambda sensor. This will tell you what the air-fuel ratio is coming out of your engine on that side. The ECU will use that to correct your readings so that your fueling is hopefully correct. It has a limited range, so if you go too far out of sync with the mapping of your injectors, of your intakes and so on, then you'll end up throwing a code and the car will run rubbish. After that first oxygen sensor, you've then got the primary cat, and then after that you've got a traditional narrowband oxygen sensor, which is there to check that the catalytic converter is working. After that you go into the mid pipe, where you've got 2 more cats, and then that joins together, and then you've got your cat back section of the exhaust. Some of the big gains on the GTR can be achieved with a mid pipe, which removes these 2 cats, and that doesn't throw any codes. Additionally, removing the downpipe cats or improving them with high flow cats, depending on your preference and environmental legislation in your area and whether the car is used on-road or off-road, that can give a real great improvement in spool up and in power. But if you remove the downpipe cats, you need to delete codes P0420 and codes P0430 in the ECU so you don't throw those codes. If you do run the car, you'll get a check engine light, but the car will run normally. Okay, rounding up, a couple more bits and pieces on the front here. This area here contains the variable intake cam timing for one bank and the other. There's some solenoids here and here, and they work on oil pressure to swing the inlet cam around for you. Inside there, which I can't quite see at the moment, there's also sensors that detect the position of the intake cams to make sure that it's getting to the target that you select. Usually we advance the inlet cam during the mid-range and during spool up. This increases valve overlap and helps turbo spool and torque, and then we retard it towards the top, because on a turbo engine you've got a big turbo that's sitting in your exhaust blocking it, and that creates exhaust pressure, exhaust manifold pressure. That's what drives the turbine. Now that is in some ways a bad thing, because at high revs, as you're starting to make the most out of your turbo and reaching its flow limits, that exhaust manifold pressure is usually higher than the pressure in the inlet manifold. Okay, when that happens and you've got valve overlap, exhaust gas can go the wrong way, and that means that your cylinders don't empty, and that's bad because you're getting less airflow through the engine, less efficiency, and also the end gases after combustion are not nice things to try and reignite, and the engine tends to detonate. So that's one of the reasons why just adding boost forever is not a good idea. What we're aiming for is best mass airflow, and then making efficient use of that depending on the octane of the fuel that we're using, by using the appropriate ignition timing to get the mixture to light off at the right time to give a nice smooth even burn, where none of the mixture explodes before the flame front has reached it. Okay, that about wraps this up. I hope that's been useful. Please let me know. Thank you.